Okay, we're going to review about the cross product today. Actually, maybe you've never heard of the cross product. Now, we're getting into maybe some non-review stuff, I guess. But anyways, here's the cross product. Basically, it's another way to multiply vectors. So far, we've done scalar multiplication, we've done the dot product. Now you have the cross product. Okay, so if you haven't figured it out, vectors are kind of weird. And I mean, they're simple to work with as far as, the algebra and everything, but the notation and the concepts are kind of fuzzy. And, on top of everything, it just seems like the books make these things out to be tougher than they are. I mean, you see all this weird IJK business and you see all these extra problems and it just doesn't add up. It looks overwhelming, weird, and it's pretty boring, so that doesn't help either. So, but basically, if you cross two vectors together, like I've crudely drawn right here, you will actually get another vector. And it's going to be perpendicular to the two vectors you crossed, okay? And it also matters the order in which you cross them. Like here's V cross W, and here's W cross V. So as you can see, this one's negative, and so on. So I guess if I want to get technical, I should put my right angle symbols right there. But, you're just going to have to kind of trust me and work with me on there. And visually, I wish I had something better to work with, but, here are some pencils. This pencil right here is the cross product of these two pencils, okay? And this vector here is the cross product of these two pencils, okay? This one and this one. And this pencil right here is the cross product of these two pencils. And likewise, if I just reverse the order in which I take the cross product, and we'll learn that, the cross product of these two is this is the cross product of these two vectors, okay? So you can see that, I don't know, it might be useful to want to know how to do something like that. Maybe if you wanted to score a perpendicular vector, that would be a good way to go about doing it. So, okay, well, enough of that, and that's really all you need to know about that. There is kind of a method. Oh god, I'm out of paper. Hang on. No, I'm not. I'm good. Okay, there is kind of a method of computation. Okay, I'm going to introduce you to it. So let's say that vector v was equal, and I'm going to use the IJK stuff this time. Let's say it was 2i plus 3k minus, dang it, I messed up, hang on. Here's vector, so it was 2i plus 3j, that's the one I'm looking for. And let's go minus k. And I get w here, and that's just going to be I minus 2j plus 2k. Okay, we'll do it like that. Okay, basically what we're going to do is called setting up a determinant matrix. Okay, and well, let me just do it. V cross W. Okay, there's actually quite a bit to the why we're doing this, and it's mainly kind of derived from a class called linear algebra. It's very boring, but it's useful. It's just unfortunate that it's very boring, okay, at the same time. Okay, so we get 2, 3, negative 1, 1, negative 2, negative 2. Okay, now I've set that up. Basically, what we're going to do here, this is the way you'll do it every time. And like I said, there's more to this, but let's just do it this way for now, okay? Because we're just using it to do other stuff, okay? Basically, you write IJK up here, okay? And then write your vector, as a row, and then your next vector is a row. I hate to just tell you to do stuff like that without any reason, but, we need to get on the ball here. So there is a process here, okay? And we're even going to set up another submatrix right here. So we're going to set up the I component, okay? And we have another matrix, and then we write our I there, okay? Then we subtract, and we put another set of brackets here, and we do the J thing. and then we add the last guy here, okay? So here we go. So, and this is the best way to do it, is you want to cover up, you know, when we fight, we're going to fill in each one of these boxes. So we'll take like basically the bottom corner and we'll stick them in here. Okay, now we got to fill the middle box. So we cover up the middle. Okay, we go 2, -1, and 1, 2. Now we're just going to cover up the last one. We're just going to use this lower box right here. The lower corner of the determinant matrix. Okay, now we've got, it kind of looks like a vector, but we have these big boxes full of numbers. Okay, so the next thing we're going to do, basically this A, B, C, D thing, whenever you see a little 4x4 determinant matrix right here, this means A times D minus C times B. Okay, so let's just do it now. We'll go diagonal minus the other diagonal. Okay, so we'll go diagonal minus diagonal. Okay, so what's the first one? Okay, so we got 6 minus -2 times -1, that's +1. Okay, so we'll go ahead and do that. Then we get 2 times 2, well, that's 4, minus -1 is +1. That's our J component. Then we got 2 times -2, well, that's -4 minus 3. And there's the K component right there. So now we're just going to simplify this a little more, and we get, what do we get? We get 4i minus 5j minus 7 K. Okay, I didn't mean to say it in K, but it kind of came out that way. So that's basically the process, and like I said, you know, there's more to it. If we really wanted to show why that works, we'd have to go into some linear algebra. So we're gonna kind of omit that for right now. Okay, so basically, what this invites to the party is the equation of a plane. Okay. The equation of a plane, okay, and we'll probably do that in the next video. So I don't think I have enough time left to do some examples of dot products, but we can always do them in the next video. So I think I'll see you then, all right? Thanks.